apply the power on those sides based on Joule heating effect, which is the science that the resistivity changes and the heat flow will change. That's the way interface electronics are behind with the batteries. Then whenever you need, you can stretch this out up to 270%, as well as that you can maintain with various cycles, the change in resistance, this kind of situation. So when we have done that, you can actually use it in variety of the locations, and you can heat it up to 45 degrees Celsius for applied voltage of 3 volts, and ramps up in less than 10 seconds. These are some thermal imaging. And you can see the more voltage you apply, but you have to be careful because it means that your battery is going to be large enough. You can actually shoot it for higher temperature, but you don't need to. We also actually came up with because like our tongue, when we are talking, that's an actuator, but when we are eating, that's a sensor. So this same thing can also sense the temperature. So we developed a Bluetooth applications based on this device, so that the blue is on the colder, the red is on the hotter. Someone can actually who is not using a low cost numeric but on the pneumatic button solution can actually set the temperature, and it's continuously measuring the temperature of the inflamed location and apply and calibrate the heat accordingly. So precision heating, as well as the real time with the real time feedback, or someone is falling asleep, they can actually set the temperature, but under no circumstance it's going to give a burning condition to you. So having said that, today we are now actually taking this for applying for the hyperthermia to destroy the cancer cell. Unfortunately, just a week back, I lost my father-in-law because he had lung cancer. So there was so much of the fluid buildup around his lung, so that at some point we couldn't actually just get it out using the medications or incision. But I do believe that maybe these kind of technologies, maybe not from our group or some other groups, we will be able to actually have vaporize this kind of the unfortunate situations and so on and so forth. We cannot enhance the human life, but we can definitely provide comfort that they deserve. We're kind of apart from this, we actually play a lot with the sustainable household materials. This is an example of the artificial skin made with only non-compromised papers, which you can find in your kitchen room, the insulator, the sponge, the sandwich wrap, aluminum foil for baked item, so they are for the conductive material, copper foil, and then we place them learning from the the human skin in vertical out of plane architecture, so that you can do the sensing simultaneously from multiple of the sensors by using the responsive material system. If you have lost your laptop or the cell phone, you can remotely destroy it so that someone cannot fetch the data. And based on the same, integrating that microfluidics, you can see a student is actually exercising, and based on his requirement or her requirement, we can control the flow or the constituent mixture, the calcium today a little extra compared to the zinc, not having the same pill, which actually Usain Bolt and I'm taking the same pill doesn't most probably make that much of sense. So anyway, we see that democratized electronics, the papers which no one actually thought that they can actually work, they really can work. Affordable, easy to learn, electronics from sustainable household materials, and integration of responsive materials and microfluidics. I personally see that there are many opportunities exist. So to summarize, first question, yes, by infusing emerging materials, low-cost processes, CMOS technology can be expanded. We can make future electronics interactive, physically flexible, compliant. Silicon and other crystalline materials, which are normally rigid, they can be effectively compliant. Functionality over affordability metric can actually be improved with effective nanomanufacturing technologies. Its current applications be strengthened and diversified. Yes, of course. One example is that the stretchable displays and so on and so forth, and the democratization to affordability and interactivity is very important for wide deployment. And can we ensure this kind of flexing and stretching? Yes, by design criteria, mechanics, choice of materials and processes are intertwined, so we have to be mindful how we are actually balancing them, so that the process-induced electrical variation as well as the physical deformation use-induced variation can be contained and managed, and then persistent complementary effort between the science and engineering can actually provide us with the new insights. So I would like to acknowledge my team members, and we have been very fortunate with the evenly reassured like on the group as well as like on the different collaborators and industries who have been supportive extensively to our work. So it's been a pleasure.